Okay, let's start our class today. And we're going to go over a little bit about the midterm exam. Let's see, midterm. Here I give actually assignment, give you the initial data exploration. We call the exploratory data analysis portion. Already have you give you some sample I downloaded from the Kaggle website, and the Kaggle website actually is the reference website. You can go, and here is the data explanation of the competition, and you can download the data from here directly. I already downloaded for you. Also, you can see a whole bunch of other people contributed to this competition, and various people using various different methods. Okay, some of them doing time series analysis just like we do. I just downloaded the exploratory data analysis portion, and I posted it here online. So this is one of the examples they have from other people. The data is quite large, actually. If you look at it, the data portion is total has 5 different files. Each file has, for example, the training validation file is 114 meg, and it has 30,490 unique values and many different rows, actually. Actually, the sales price also has many different rows as well. So let me show you how big these are. So I just executed first couple ones, and I will explain how to use this file for your homework, but I'm not going to give you direct solution. You need to pick and choose what type of exploratory analysis you want, data analysis you want, and to fit the data for your forecast. And each team can perform different type of analysis as well. So first is import. The second, I'm going to read the data. Okay, read the data. It takes a while to read the data. It takes me almost 10 seconds to read all the data file. So if you have computers or laptop with less amount of memory, this could take 10-20 minutes for you. So make sure you're using a computer with a 16 gig of RAM. That's what we specify on the website, on the canvas. Probably you need that much to do this assignment. After I read it, I give you some, I do a so-called, for each one of the data file or data frame. And here they have an explanation of each one of the data file, what they mean. And the Kaggle website has more detail on each one of the data file. Okay. What we have, I just using info function to tell you how much memory of each one of the data file is occupying. Okay. So, it's quite a bit. Actually, you see that in this sell price. Actually, you have almost 6.8 million records in here. So it's quite large. And however, they only have 4 columns. So it is not that big. It's 200 some gig, 200 some meg. But look at the STV, which is the sales training validation data file. You have actually only 30,500 type of rows, but it has a 1,920 around columns in there. So it's quite big. It takes about half of a gig of your memory. It depends on how good your computer is. Sometimes it can be time consuming to load these data. So one of the things I want you to know is, and you can go through these so-called exploratory data analysis and show you some of the graph, how to look at the data in different ways, either by category of the product, or either by store, either by location, or by time. So it has a very sort of data organization. So your team and your team need to decide which type of analysis you want to do and pick and choose the one, organize the data in that way. Okay. So for example, this is actually for each type of item, for each one of a store, and it has time series analysis. And some of the data you have a household 1 and Wisconsin store 1. Actually, the first part of the history, they don't carry this product. Okay, this type of product. So only after maybe the middle of 2013, they start carrying. And the other type of analysis you can do is combining cell over time by type. So you can see for food, household, and hobby, these are the 3 major categories they have, how much is occupying the total cell. Your team can do is actually for each state, for example, California, and for Wisconsin, for Texas, I think they have 3 different states or 4 different states? I forgot. And how much percentage occupy in this total amount. Okay. And also these are the analysis based on product category and time series total amount, okay, of cells. So these are the code you can cut and paste to your specific goal or mission and perform analysis that way. And also you can do a so-called by store type of time series forecast, okay, for each one of a store total cells in terms of range. And these are the heat map for calendars, years, and how you see that always the weekend has a higher sales than the weekdays. Who is this? Huh? Oh, that's fine. Oh. So it is this one you're talking about? Okay. This is the vertical axis is the weekday. Sunday, Saturday, Friday, and so on and so forth. And the bottom one's Monday. And then you have January, February, March, April, all the way to December. And this is for each year. This is 2013, 2014, and 2015. See that? And the red represent a little bit higher cells, and the dark blues represent the lower cells. the yellow represents and the middle, and the orange is closer to red, and so on. So this is a heat map. Mm-hmm. 1, 2, 3, 4. Actually, each one of them has a 4-week period and layout by day. You see what I'm saying? Date of the week, I'm sorry. And 3 different product categories. This is one of the way to look at the data, and they present it so many different way. And you and your team need to pick which one you prefer to do the analysis. It's all on cells, but there are so many dimensions. It can be so-called store by store compared to the overall cells. And you can do stay by stay, or you can do product category by category, and they all have a time series domain as well. All right. So this pretty much summing up this process. I want you to, this notebook is not a solution. You don't have to do everything in here. What I need you to do, you and your team, take an objective. I want to do store by store sales against the total sales and forecasts over time series. Make sense? One of the thing is I want to mention, some of you, if you load all the data, if your computer is kind of dated or slightly dated, and you might have a trouble after you load all these data frame all together. Okay, you probably just need 1 or 2 data frame at a time, and after you perform, reorganize the data. For example, let me see. Let me give you an idea. Initially, the data looks like this, for example, okay? And then you have a day 1 all the way to days 1751 and beyond. And you need to convert it into daytime series. So you need to combine 2 data frames. So this is actually the training verification set you have is 400 meg already. Then you need to merge with this calendar. So each one of the day, D underscore something, corresponding to a day over here. See that in the calendar? So you want to merge them. So this is example how you can merge the training verification data set using a daytime series. And so now it converted to daytime series. Okay, and then you can do your forecast using exponential smoothing. Am I right? I think what it is. Exponential smoothing and Ho and Winters and Sarimax and so on. All right, so these are the things you can perform, but you need to take your M. Are you doing store by store compared to the overall sales, or you do a category by category time forecast, or you do it by region time series. Okay, so you can do California, Texas, Wisconsin. I forgot actually 4. Okay, yeah, 3 state. 4 store in California, 3 store in Texas, 3 store in Wisconsin. So you total have 10 store to compare with overall. And you have 3 product category called food, which is the biggest sales, and hobby, and what is household. So, and your team has to pick the one. And then this initial data exploratory notebook has all how to organize them into your objectives. So you don't need to do every one of them. But the thing is, after you done massage your data, since you forming a new data frame using the existing data frame, so you double your memory usage. You understand what I'm trying to say? So once you're done, you need to quickly delete the old data frame. You don't need it anymore. And just using DEL, delete data frame. For example, here I have a data frame called SS. If I want to delete this data frame, all I have to do is adding a column, say delete SS. Oh, I'm sorry. Sorry. I'm adding this, just say delete SS. Okay? And execute. It will remove that data frame from your memory. So you freed up more memory for your further analysis. Otherwise, once you in homework, you always do a copy one data frame to another to perform analysis. Those are increasing the usage of your computer memory. And for small example we have in the homework, that's fine. But for these size of a data set, you need to be carefully manage your data frame sizes, and do you still want to use them or not. And I will, some of you asked a question before. So if we want to delegate the work from one group member to another, maybe one of us want to do the store by store, the other one doing category by category. Can we using we have to read the raw data twice? And you don't have to. One person can have a better computer, can actually perform the initial analysis and export and save the massage or reorganized data frame and share with your team. And so your team member may not have as good a laptop as you have, but they can, using a small data set, perform their separate responsibility for doing the analysis. Understand what I'm trying to say? So one person with a better computer do all the data exploratory and save it as a CSV file for other students. For example, we total have 10 store. Maybe two of you, each one of you doing each state, for example, and you can have a same data frames separate into 3 states and save it on the hard drive, and each one of the team member just need to load that state. You understand what I'm trying to say? So be creative. Since this is a little bit sizable data frame in your memory, I think the overall usage of the memory almost close to 1 gig. With the analysis you need to do, we have a student in the later part of the time series, for example, Holes and Winters and Cerimax analysis. Probably I have a student report running for hours. Any question for me? Hmm. Say that again? Score. I, oh, you mean scored up here? The size of the data frame? Hmm. Here? I don't think so. Oh, this is a calendar. Don't worry about it. Yeah, you just have to match the D with the D over here. You see what I'm saying? And the snap is actually in Venn. We didn't do any kind of invent and ISIS. This is called invent and ISIS, meaning they have that day they have a specific discount event or promotion. You understand? Coupon type of event for the retail store. They can correlate if you have a discount coupon or special promotion, and is that going to affect the sales volume or not? Hmm. Like this, you talking about like this. You have a food altogether, correct? And you can do like a California, how much percentage they are in each one of the category, and then what kind of for food, what type of seasonal, trend, type of patterns for overall category like this. You see what I'm saying? The food actually is up here, and you can tell they have some kind of trend up and downs, and they have a specific pattern also. You see what I'm saying? Or three, yeah, 28 day for 30 days, or 300. Some of you did it 356 day. So you kind of, figuring out for food items, for hobby items, and how much of a, how much of a sells for that item. You can actually Walmart do this all the time, and just trying to predict what kind of order they need to place with the vendor. Many times their items, food item may not be the case, especially the produce item. They're all contracted out at the beginning of the season or quarter, and they have a set of price. So doing that price things advantage, and it creates a tremendous advantage for Walmart to purchase, for example, apples or corn in the next 3 months. And it is much easier for farmer. They have a planted culture as well. They can estimate how many corn they need to plant, how many apple they need to plant, and so on and so forth, or harvest. And so a predictable plan is very important for supply chain like this. And hobby is the same thing. And you all know at the end of the years, and especially over the so-called Thanksgiving to Christmas period, the hobby items and household item went up 400%, and sometimes it's 2,000% of the yearly sale. So you're welcome to do so-called category forecast that way. You understand what I'm trying to say? You guys can do what is it? OneDrive you have? You understand? You are welcome to create your own team on the Microsoft team. The file you upload is shared by the whole team. You can. Yeah, share the document you can share on the screen, and each one of the member can take a control. You understand? Like many of my students share, actually, MIS is the same thing. You share your notebook with me, I take a control, and I drive for a little bit, and I let you do the control. So I'm not 100% you need all four people added in the same notebook at the same time. I think you can do so-called in terms, correct? Who takes the control, they can actually add it, the notebook. Yes. The only tricky part is you have to share your screen, not a specific window. Okay, that's the only thing. So one guy shared his or her screen with all the teammates, and then you can dispatch all the control to all the teammates you use. And you save the result notebooks on OneDrive, so everybody still got a final copy of most current version. Any other question? Part two? What is part two? Sure. I think the airline passenger notebook, it just give you example how you perform the analysis. You have to, you're still using the data. Let me check. See if I can pull it up. Just a second. Time series. Did I have somewhere? Oh, I think it's right here. Okay, let me download directly from here. Yeah. Give me a sec. Hmm? Okay. Which part you are referring? Hmm. Oh, because some of these models don't work. The combination here, you have all kinds of combination of parameter. It's additive or multiplicative models and seasonal. What is the seasonal pattern is, and you know, yeah, because this is you kind of all expanded together, blended together. So I think there are 70 or 68 total models you run. Yeah, 71 actually. And not all of them are valid. So some of the combination don't work together. So if it's not working, they just skip. You see what I'm saying? Why forecast? Where is it? Here? Okay. Yeah. Mm-hmm. If you want to using test size, you should probably using so-called length of test, correct? Is that right? I think this is the one I did it with. I split the test and training. Test is before 365, and test is 365 and beyond. So I did it with the lens with test. It went okay. And I performed, what is that? Rule mean square arrow and printing out each iteration. All of them are working okay. I did it yesterday for another team. No, you using the trend to fit the model, correct? Trend set to fit the model. And then you using, you do the forecast. After you forecast, you compare the tests with the forecast number. That's how you calculate root mean square error. Did that make sense? Initially, you can decide if you wanted to only the last 28 day. So here you just do 28, correct? And this is only up to the last 28. So it's up to you how you want to do this. But I just did a 356. I'm trying to see if the prediction are okay. It's up to you. You can do 100 day, 180 days, or 120 days as a quarterly estimation of forecast. So you can do that, no problem. Okay, and the only thing is you have to, your forecast value has to be consistent with your task data set, and then you can compare the mean root square error. So some of the errors, the original file airline is, I think the time period was forecast is 12, but this data set is not actually. This data set has very different time pattern. If I remember, you can look at this. Am I have it done somewhere? Oh, okay. Here you can see that. For different store, they have a very different seasonal pattern and the trend pattern. Okay. I think you start with the 7 days, and you can do 30 days. You can do 356 days. I tried it, all worked. Yeah.